Okay, this is the second video on lesson 5.4, part 2, graphing rational functions. We just did example number 2, and now we're moving on to example number 3. So first things first, horizontal asymptote. In order to do the horizontal asymptote, we have to think about the degree in the numerator. This is 5x to the 0 over, and if I multiplied this out, the denominator would be x squared minus 4x plus 4. Now, I don't actually have to figure out this whole thing. I just need to know that it's degree 2 on the bottom. Looking at the degree in the numerator and the denominator, I can tell that this is bottom heavy. If it's bottom heavy, if the degree is larger in the denominator, my horizontal asymptote is always y equals 0. On to the vertical asymptote. For the vertical asymptote, I take my denominator and set it equal to 0. So x minus 2 equals 0 leads me to a horizontal asymptote of x equals 2. Alright, let's graph the horizontal asymptote at y equals 0. We want it to be a dashed line because it's not actually part of the function. And then x equals 2. That's our vertical asymptote, dashed again. Okay, are there any holes? Are there any factors that cancel out in this function? No, nothing cancels. So there is no hole. X-intercept, remember we do that by setting y equal to 0. So 0 equals, and the shortcut is just to set it equal to the numerator. 0 equals 5. Can 0 equal 5? No. Because it doesn't make any sense, it means that there is no x-intercept. There we go, no x-intercept. So when I graph my function, I shouldn't see anything crossing the x-axis. Now for the y-intercept, set x equal to 0. So we get f of 0 is 5 over 0 minus 2 squared. This is going to be 5 over 4, or 1.25. So I'm going to go to the y-axis for my y-intercept and plot a point at 1.25. Now, it's not precise on here. It's kind of hard on this video to make it precise, but it's close enough. Okay, now we're ready to ask, where does our function go? Let's start on the left-hand side of this graph. So remember, it's divided into a left and a right. On the left-hand side, we have to go through this y-intercept, and we have to hug the asymptotes. So I have to go up towards my vertical asymptote and down towards my horizontal asymptote. And I've done the left side of the graph. There can't be anything down here because then we wouldn't pass the vertical line test. It wouldn't be a function. Alright, we're ready to look at the right-hand side. Now, my graph could be up here in the right-hand or upper corner, or it could be in the lower corner. There isn't actually any way for me to tell so far where it would be. I'm going to have to actually plug in a point to test it. So let's do f of 4. That's going to give me 5 over 4 minus 2 squared. So that's going to be 5 over 4. 5 over 4 is 1.25, so we're back here. So this upper graph, or the right-hand side of the graph, has to be hugging the vertical asymptote, go through that point, and then down towards my horizontal asymptote. Now, there is actually a trick that will allow me to figure out where this goes without having to plot the point. And that's what I've got down here, this tangent together. When we learned about polynomial functions, if something had a multiplicity of 2, so if we had x minus 2 squared, it touched at x equals 2, but it bounced. Right? It touched but bounced. there's a similar idea here. If you have a multiplicity of 2, so one of your factors is squared, there are two possible scenarios. If your squared factor is on top, so if it's in the numerator, your graph will be tangent to the x-axis. It will bounce, just like with the polynomial function. It will bounce if you have a multiplicity of 2 in the numerator. If your multiplicity of 2 is in the denominator, it means your graph will come together. So if we look at this graph, we can see it's coming together. Oops. Get that T in there. Together. So because we had this multiplicity of 2 here in the denominator, the x minus 2 squared, our graph comes together. All right, on to our next example. All right, this is example 4. We will have to first start with the horizontal asymptote. Let's take a look at the degree. They're both degree 2. Since it's balanced, I'm going to look at the coefficients. It's 1 and 1. So my horizontal asymptote is y equals 1. My vertical asymptote, I have to look at the denominator. Before I can find a vertical asymptote, I have to simplify. I have x plus 1 divided by x plus 1. That cancels out, and I'm left with x minus 6 over x minus 1. So I look at this denominator to get my vertical asymptote. My vertical asymptote is x equals 1. Next, I can think about the whole. The whole, I look at the factors that canceled. X plus 1 equals 0, so x equals negative 1. My whole will be at x equals negative 1. I need to plug negative 1 back into my simplified function to find the y value. So y equals negative 1 minus 6 over negative 1 minus 1. That gives us a y value of negative 7 over negative 2, which is 3.5. So our whole is at negative 1, comma 3.5. Our x-intercept, we set a y equal to 0, or just the numerator equal to 0. Remember, that's the shortcut. So 0 equals, our numerator was x minus 6. And when I'm solving for the x-intercept, I want to use the simplified function, x minus 6. So our x-intercept will be at x equals 6. So we'll have a point at 6, comma 0. Okay, let's finish this off with our y-intercept. Set x equal to 0. Plug it in. And we can actually plug this into our simplified function. So we have 0 minus 6 over 0 minus 1. That gives me negative 6 over negative 1, which is just 6. So I have a y-intercept at 0, comma 6. All right, we're ready to start plotting these features. So we had a horizontal asymptote at y equals 1. We have a vertical asymptote at x equals 1. We have a whole at negative 1, 3.5. It's a little bigger than the whole should be in your notes. Make it smaller. We have an x-intercept at 6, 0. Use a different color just to highlight it. And then we had a y-intercept at 0, 6. Okay, time to graph our function. Let's start in the left-hand side, and then we'll go to the right-hand side. On the left-hand side, we have points that are clearly here. We need to go through that point, go to the whole, continue on, and hug the asymptote. Oh, I went forward a page. Okay, back to our example. So we're hugging the asymptote. In the right-hand side, we have a point here on the x-axis. I need to go through that point. But I also need to hug my asymptotes. So that's where my graph goes. It has to go in one of these quadrants each time. Here it had to go through these points. On the right-hand side, it has to go through your x-intercept. We don't need to actually test any points here. Alright. We'll do example 5 in the next video.